Okay, so let's see how a set can be represented by its bit string, corresponding bit string, and how um, we can find the basic set operations like complement, intersection, and union using simple bit operations. So let's say we have a universal set which is uh, 1 2 3 4 5. So this is our universal set. Okay, so since we have 5 elements in the universal set, so each bit string in our corresponding set will have 5 bits. Okay, how to form a bit string now? Now any subset of u, let's say a is equal to 2 4 and 5. So any bit string now the first position corresponds to 1 2, second to 2, third to 3, and so on. Okay, now we say whether element 1 is in a, it is not, so we put a 0 in the position for corresponding to 1. Whether the element 2 is in a, yes. 3, no. 4, yes. And 5, yes. So this is the bit string which corresponds to our a here. Similarly, let's say we have an empty set here, so this corresponds to 0 0 0 0 0 because it has none of the elements in u. And similarly, if we have c is equal to u itself, so then it is represented by 1 1 1 1 1. Okay, now let's say we have an in bitwise OR operation. So bitwise OR operation means what? That 1 or 0 0 or 1 1 or 1, they give us 1, and 0 or 0 give us 0. Okay, and similarly we have an AND operation, so 1 and 1 give us 1, and 1 and 0 0 and 1, and 0 and 0 give us 0. Okay, similarly excuse me, we have a NOT operation, which is 1 not not like this, NOT of 1, this give us 0, and NOT of 0 give us 1. Now let's say we have to take a is equal to again 2 4 5, and b is equal to maybe 1 3 5. Now what we want to take is we want to take a intersection b. So in terms of set notation, we know that intersection means all the common elements, so it is straightforward to see that the answer is just 5. But now how can we use bit operations to do that? Okay, so now intersection, intersection corresponds to AND operation, and union corresponds to OR operation. We'll see an example of union in a bit. Okay, now a intersection b, a is what? A is our 2 4 5, so we have 0 1 0 1 1. And what is b? B is our 1 3 5, so b is our 1 0 1 0 1. So now we are going to AND them bitwise. So 0 and 1 0, 1 and 0 0, similarly 0 0 and 1. So this corresponds to a set of which only has the element 5 in it, so this gives us the corresponding intersection. Similarly, we can take a union b, which will be equal to 1 2 3 4 and 5. Now let's use the OR operation in finding a union b. So we do OR, so we can see this is 1 1 1 1 and 1, which corresponds to u itself. Okay, and then we talk about complement. So we have a complement, this is equal to 1 and 3. So a was what? So the complement of 0 1 0 1 1, this is equal to, so we flip all the bits, so 1 0 1 0 0, which is equal to again 1 and 3. So this is a pretty simple way to, if somebody is familiar with basic bitwise operations, they can use this method as well to find basic set operations. One implication of this is that if you want to find the total number of subsets of a set, so for example if u has 1 2 up to n elements, so then how many subsets can you find? Because now how many subsets can you find? So each subset we know that is represented by n bits, and each bit can take either 0 or 1. So this means that number of subsets in U should be equal to 2 to the power of n, which is also the cardinality of the power set of U, because we know that power set is a set of all subsets of U. So this is a pretty simple method of of thinking about sets. If you can make a bit string out of each subset of our universal set, you can perform the same operations as we already know as intersection, union, complement, and so on. So this is about it for the sets and their bit string representations. Thanks for watching. Hope you like the